Hello, everyone. Thank you very much for joining us today. My name is Scott Sugden, Product and Technology Manager here at L-Acoustics. I am really excited for today's presentation. We've actually have a really special guest with us, Nick Payne. Nick, you are on air. You're coming to us from, where are you exactly? You're in England. You're just north of London, is that correct?
Correct, yeah, just north of London, between London and Cambridge.
Well, thank you for joining us, Nick. Today we're going to talk all about the Rammstein stadium tour across Europe from, was it summer and fall of 2019? Is that when it was?
Yeah, correct. Yeah, we ran from beginning of the summer to almost the end of the summer.
Oh,
25 shows.
Oh, fantastic. And you brought along, and we have Nils with us as well. And can you explain and introduce Nils for us?
Yeah, absolutely. So one of the first things to say about the whole Rammstein operation was that the whole thing was a really big team effort right from the start. So the initial part of the conversation with production was done by Andreas Vader, who has been a long time system engineer, system tech for Rammstein. And then Nils was brought on alongside me and Vader to help with the system design and tech the system. And so actually Nils ended up doing quite a lot of the legwork with the sound vision.
Fantastic. Nils, thanks for joining us today.
Hey, thanks for having me. Hope everybody's doing all right.
And Nils, you're calling from where again?
I'm coming from Mannheim, Germany.
Mannheim. Oh, fantastic.
Yes.
Excellent. Guys, just before we get started into your presentation today, Nick, and the conversation we've got set up for the Stadium Show, I just wanted to introduce everyone who's watching on the web to our moderator panel. They're going to help answer some questions and field some questions. So first, I guess, let's keep it in Germany and bounce over to Martin Rode. Martin, how are you today?
I'm very good today. Sunny weather here, and I'm happy to assist again as a moderator. So if you have questions in German, you can ask in German. Ihr könnt das alles auf Deutsch stellen. Ich werde in Deutsch antworten, sofern es mir möglich ist, da ich natürlich bei der Rammstein Crew nicht persönlich dabei war. Und viele Fragen werden wir dann auch in das Webinar weiterleiten müssen, sodass Nick und Nils direkt antworten. Vielen Dank.
Excellent. And heading slightly to the west, Arno, how are things just outside of Lyon?
Hi Scott, hi everybody. Everything's fine there. Very happy to have all our friends with us today. So this will be a great webinar, I guess.
Excellent. Thank you, Arno. And obviously, Arno will be able to help answer any questions you guys might have in English or French. Tony, once again, it's good to see you. I hope all is well. Did I see some new decorations in your office today, Tony?
I don't think so. What happened? What's been added? No. Okay. Oh, you mean the sun? Yes, the sun's come out. Hi from sunny UK.
Excellent. Thank you, Tony. Tony's going to help out answering questions. And last and definitely not least, let's head south to Guadalajara, Mexico. Alex, how are you today?
Hi, Scott. Everything's fine here. Sunny day, another beautiful day here. Really happy to join you guys. Welcome, everybody. Bienvenidos todos. Aquí vamos a apoyar todas sus preguntas en español. Va a ser un webinario muy interesante. Espero que lo disfruten mucho. Thank you, Scott.
Excellent. Thank you, Alex, for joining us today. And so, guys, if you are out there watching along today live, please don't hesitate to ask questions to the moderator panel. As always, it's a bunch of experts who can help you understand better some of these concepts that we might be talking about today. Nick, so where do we start? Where does a tour like Rammstein start? Like, how do they come to think about something like that?
So for a start, we'll just show everybody probably something that's been seen online a whole bunch of times. But this is the end result of everybody's hard work. So this is the show that quite a lot of people came to see, which is kind of cool. Big rock show with lots of fire. So the brief actually band through production are really passionate about making sure that all of their audience experience good audio. So they, having toured arenas quite a lot, but never toured stadiums, had some concerns that they wanted to put out effectively the same show in a stadium that they were putting out in an arena. So they want the same experience for the whole audience, and they want audio that reflects the show. I mean, it is a show. It's not just a concert. So it's a big, immersive, intense, very big show. So they're concerned about getting adequate SPL at every seat in the venue. And the quote we got from one of the band was that they wanted the best possible stadium sound. The concern being that stadiums are notoriously difficult to get right.
And so you say the best possible quality, like do you have, oh, there you go, the details on it. There you go. Thanks, Nick.
There we go. So that's all right. So the initial design process we went through was that we had to achieve a number of metrics in all the seats in the stadium. And Andreas Vada did quite a lot of this initial legwork, looking at how to achieve acceptable quality in terms of tonal balance, and particularly in the stadium intelligibility, because Rammstein is one of those bands where everybody likes to sing along. So if they can't hear the lead singer, then that's going to be a struggle. And in stadiums, intelligibility can be an issue. They're also concerned that there's enough STL. They want a show that has impact. They want people to feel the show, to be able to feel like they're involved in the show, irrespective of where they're sat in the stadium. So you need both of those things to be able to achieve that. Because of the set, and I'm sure a lot of people have seen the set, because of the set, which is this enormous bespoke constructed thing, the flying locations had to be really carefully determined alongside the lighting and the set department. And we'll see a little bit later on that some of the rigging solutions that had to be created were quite unique and quite cleverly put together. So there were quite a lot of negotiations about where we could put speakers and the lift capacity available. The towers, though they look very big and they're made of big bits of steel, actually the towers are holding a lot of other things. They're holding lights up and bits of video and all sorts of other things. So actually we had a relatively limited lift capacity for such a big structure. And there was also quite a negotiation about ground locations of things because of the number of special effects in the pit, and the fact that there are moving set pieces that track in and out of the pit as well. Though the pit, if we see this photograph, looks like it's quite big, actually the pit's a pretty busy place. You can see the confetti blowers poking up there between the subs next to the arcs. And actually, what you can't see behind all the subs, we've had to space the subs off the edge of the stage to make sure there's enough space and clearance for all the flame heads that are sat behind there as well. So we're quite limited in space, despite the fact that it's a stadium tour. Sightlines are another issue, another big concern in stadiums. They were selling stadiums out, so we had to make sure all the seats had acceptable sightlines. And there's a picture here of a typical stadium. And you can see right up at the top of the roof structure, the house system, and then flown down below the roof structure, you can see all of our ring delays. So we had to be fairly careful where ring delay systems were sited to make sure that we weren't obstructing sightlines and blocking seats for a view from the stage. Interestingly, this system had to cover small stadiums and large stadiums and stadiums played sideways, but we also had to cover greenfields. So we ended up doing 2 or 3 festival shows. So we ended up having to do this kind of thing, which makes it interesting in building the towers, particularly the ground delay towers, because we're having to make sure that we had enough space on the tower to be able to get enough down angle with the systems hanging off the towers to cover the flat floors. Transport was another concern with the initial design as well, because we actually only had 5 trucks to carry the whole thing, including the ring delay system, which isn't a huge number of trucks for such a big system. So from that initial design concept with the production team, we went into pre-production phase, and this was a really collaborative thing between Andreas, Nils, me, the guys at Solitech SSE in Redditch. And we were then looking at how we fitted in with the set once they'd kind of figured out where we could go, and talking to them about load and positions. And from that, we ended up creating some basic sound range files, which were just speaker files to start with. So we were looking at the different options that we knew we had to lay out during the tour. So an option for a stadium with 3 ground delays in it, an option for a stadium with 4 ground delays in it, and actually each of those different options has 2 versions. So there is a longer version for big stadiums, for big long stadiums, and a shorter version for shorter, like smaller football stadiums, that kind of thing. And then another file which has all the ring delay information on it. So the ring delays were determined on a stadium by stadium basis, and by the ring delays I mean the delays flown out of the roof of the stadium. But they're determined on a stadium by stadium basis, depending on where we can fly them usually, and where they have lift capacity in the roof.
So you had a version of the file for large stadiums. So this is like the Olympic size, where they have the Olympic racetrack kind of thing.
Yeah.
And then for a normal football pitch or soccer pitch, if you will, you had a version for that as well. Now, did you build these just as templates to give to production, say, here you go, guys, pick what makes the most sense, or was this your buildup of work so that it was easier to switch between different operating modes?
So this was at this point this was a completely bidirectional process. So the production team were telling us that because we have pyro and lights on the delay towers as well, the production teams were telling us in an ideal world where they would like them, and then we were going back and negotiating with them and saying, okay, well that doesn't really work for us, so can we slide it a little bit this way, a little bit that way? And so for each venue, once we get to the point where we have a basic idea of where we want to put them, and we've done the negotiations, and some of those negotiations are purely based on an acoustic thing that, we need to get the speakers in the right place. Sure. And some of them are based on practicality, like if we want to push the outer ground delays way out to the edges of the pitch, but the roof is overhanging that bit of the pitch, we can't put them there because the flames are going to hit the roof, and that's not acceptable. So it's one big compromise over all different disciplines. So it's not just us that's determining the position of these towers.
Got it.
Once we generated all of that information in terms of the speaker files, then we could take that to the SoundVision venue files and then start laying speaker files into individual venues one by one and figuring out which was the best solution for each venue. And so we ended up creating 25 separate SoundVision files for all the venues. Some of those were generated from existing drawings. Some of them were generated with support from the L-Acoustics touring team, converting AutoCAD files. And once we had that, then we went through the process of refining and figuring out all the SoundVision files. And
obviously, at this point, it sounds like this is weeks or months worth of work. When did you get started on this? When did Nils jump in on this picture? When was that scenario happening?
So Andreas Vara kicked all this off about 12 months out when they first started talking about initial concept. And that then came to SSC Solotech at about 6 months out. I got involved shortly after that. And then once we had a good idea of the SoundVision files, a bit closer to the actual on-site production time, Nils got involved to start refining SoundVision drawings. So it was a real big collaborative effort between a whole group of us. It wasn't just one person who dealt with all of this. There was a whole load of collaboration, negotiation between us and production, and figuring out what was in terms of equipment, what we could take, what we couldn't take, and all the rest.
Got it. Oh, very interesting. Wow. It's like my mind is like spinning to think about all the different scenarios. Plus, you had to work within the confinements of the allotted gear, plus stadiums that are vastly different. I can only imagine some of them are maybe quite easy and nice, and some of them are immensely challenging.
Yeah, absolutely. I mean, one of the things we're really lucky with Rammstein as a band, and we're really privileged to work with their production, because in the most part, and I'm not saying we had carte blanche to do what we wanted in terms of equipment, but in the most part, when we said this is what you need to put the right solution in, the answer was yes, because the band were involved at that stage and wanted to do the best job they could. So once we'd figured out cabinet counts and we'd figured out where things needed to go, then we started looking at amplification and drive systems. So because of the nature of this system, we ended up using LA12Xs across the entire system. So absolutely all of the amplifiers were common to that platform. And once the amp rack locations were figured out, we could determine racks and rack designs. And you can see a picture there of all the racks just before they left the warehouse. We ended up carrying 186 LA12Xs, including the spares, which leads on to some really interesting conversations about power per rack, because that kind of number of amplifiers, we're talking about quite a lot of power requirement. This gives you an idea of the pre-production designs for the amp racks. So this is the information that we pushed onto the warehouse so the guys could pre-build the racks for us. So you can see what the amp is doing, its IP address, all laid out nice and neatly for the guys to build the racks off, and that's what they ended up creating the racks you saw on the slide before from. So here's a couple of photographs just to show people some detail of the amp. So that's one of the main stage racks. So that's 25 LA12Xs in one rack. And then in the center bay, you can also see there's a motor controller and there's a custom built distro. So every amplifier is switched individually, as they should be. And that has 125 three-phase C-form going into the back of it to power that rack. So that's one of the main hang racks. That's one of the side hang racks. Same rack frame, all identical, just has 5 amplifiers less in it. That's the back of one of the racks. So you can see that 25 C-form connector sat on the floor there. And then on the right-hand side at the bottom of the rack, you can see the LK25 multi-core connectors, which carried signal up to the speakers. So for the main hangs, with the big hangs, in fact the side hang as well, actually we only have 4 cables feeding that whole hang, which is great. It makes cable management much, much easier. That's the back of one of the racks loaded with all of its cables now. So you can see the LK25 connectors on the bottom right-hand side going out of the rack. And then in the center of the rack, the connectors with the green tape on them, you can see an analog connector there, which is carrying the analog back up. And next to that, you can see the fiber connectors that were going in and out of that rack. So the whole system was carrying AVB over fiber. We'll get into a little bit of a look at that later on. The racks had to be covered because the racks actually sit on stage completely in the open. If it rains, the racks are in direct danger of getting wet. So they have these custom covers made for them, which keep them dry. And during the show, actually, most of the time we were running the show with the covers down, with the racks sealed shut. So those covers are pretty good in terms of airflow. We didn't have any heat soak issues with the amplifiers. They all sat there doing their job perfectly happily, even in fairly high ambient temperatures.
Yeah.
The only time we had issues was during the day in the sunshine. We had to open the covers sometimes.
Yeah, if I recall, last summer was slightly warm in Europe. If I remember a few of those days, record heat. So that's a pretty good sign that there was adequate ventilation. If the 12X 25 LA12X was happy underneath the cover in that kind of heat. So.
Yeah, Barcelona was probably one of the warmest shows we did, and we definitely had to have the covers open during the day for that. But then once we get into nighttime, we can shut the covers.
Got it. So now the covers are obviously for rain.
Yeah, absolutely.
Yeah, and are there like other concerns that made that a necessity?
It's funny you should mention that. So just like any tour, any normal, any installation, you're going to have a maintenance routine, and our maintenance routine was once a week. Every filter would come off all 186 amplifiers. In fact, it's slightly more than that because we're not counting the monitor amps. So just under 200 filters would get given to the laundry department on the tour and would get washed and then dried and refitted clean. So that was our maintenance routine once a week. And the filters are pretty critical on shows like this because disasters do happen sometimes. And there's a picture of a little oopsie. So one of the pyrotechnic systems runs on a powder called lycopodium, which is just a harmless powder they use in the flame heads, but it's under pressure. And one of the Lyco hoses let go, and you can now see the consequences of it. It looks like it's been snowing on stage. And unfortunately, the amps were all on when this happened, so all of this got sucked into the front of the amplifiers. Was that filter washing day by chance? Did you happen to have all the filters off while that happened? Thankfully, no. You can see the filters are still on there at the moment. But unfortunately, we did have to strip every single amplifier out of that rack, take the bottom of it off, and then blow them all clean inside. Oh, yeah. So that was about 3 hours worth of work to strip that rack and rebuild it. And that probably happened, at 2 p.m. on show day as well, right? No, actually, that was about 7 p.m., I think, wasn't it, Nils, on a load-in day?
Yes, it was like 7 p.m.-ish, and it was like we had 1 or 1.5 hours left to tune the system, which went down the hill that night because we had to clean the amp brake. So we had to do that on the show day then. Disappointing radio call in catering. So I was talking about power. So obviously once we've done an amp count, and obviously this is the process that everybody would go through with most normal shows, but it's just worth discussing a little bit. So once we've gone through an amp count, we figured out the required services and give that information to the guys on site. And actually for this number of amplifiers, the numbers become quite astonishingly big. So we're 100, you can see on the screen, we're 125 and 3 service for all the main stage racks, and then it steps down as you get into smaller racks. But the power guys were really on it. And we're taking quite a lot of measurements just to figure out what was going on with their overall system. And they were saying we were averaging 880 amps a phase across 3 phases at 230, 415. And that's not peak draw, that's an RMS current draw. The whole show is driven off a generator farm, which the whole show was drawing about 2,600 amps a phase, just to give you an idea of the magnitude we're talking about. We hit some really interesting issues with transient current draw, because the cables that they feed from the generators down to the stage are really long, in some places like 170 meters before they hit their first distro. We were finding that because of the instant current draw of the amplifiers being so big, that we were seeing some really weird issues with power, seeing some big voltage fluctuations and things. And actually we ended up having to put big 150 kVA transformers onto all of our power feeds, the main primary power feeds, to effectively act as a load damper. To protect the amplifiers from the swing voltages on the generator. Basically, the generators can't keep up. They just can't put power out and spin the engines up and down fast enough. It's a common problem, but it was interesting. We actually discovered it with amplifiers. It's unusual to see it on an amplifier. They usually see it more on LED lights.
Well, to mention here, it was only on the delay towers, where we had like the longest cable run from the to the amp, basically.
The generator times the amps, yeah. So once we've been through amplifiers, we get into the drive system. So we ended up using a custom-made rack from SSE, 2 displays on it, a single PC and an audio interface. And actually, it's not a very heavily loaded rack in terms of equipment. Single LM44 and 3 P1s from L-Acoustics and some bare dynamic measurement mics. And that rack looks like that. One of the interesting things we did come across when we put this rack together and initially built this was because there are so many amplifiers on the network and the network manager page is so busy. Actually, we ended up needing a 4K screen to fit the whole thing on, because otherwise we were in a situation where we were having to scroll left and right all over the place. So the things we were looking at in the network manager system and the drive system altogether was that it needed to be simple, it needed to be quick to get together, and overall, more than anything else, we had to have a reliable system. It had to work every time, all the time. So we ended up using AVB as the primary transit system from the drive rack to all the amplifiers, backed up with an analog feed on an automatic fallback. It was all driven on fiber via Luminex switches. We didn't end up using the LS10s for this show, mostly because the LS10s didn't exist at the time. And secondly, because the LS10s would have been great at front of house, but maybe not the ideal option given the number of outputs we needed on all the big racks. The LM44 is in the drive rack simply as a grab EQ. So the front of house engineer Olsen used it for the first few shows. He had the tablet on his desk with him, used it as a grab EQ for the first few shows. And actually, after the first few shows, he was hardly using it at all. We kept that. We kept it in the system just so we had it there as an option, but it wasn't a hugely used thing. And the P1s were doing AVB conversion from the AES coming out of the LM44 and distribution of all the AVB information. We were also using the P1s to drive house systems. So if we ever got in a situation where we were tying into a house system or we were feeding VIP boxes in a stadium or anything like that, then that was a lot of job that the P1s did also. So during production rehearsals, we built base files. So I mentioned that we had a 3 delay and a 4 delay system and a system with ring delays. So during production rehearsals, we built base files in Network Manager. So we had an option for each system. So the first show we actually ran each type of system with, we would fire that file up, modify it, tidy it up, get it to exactly how we wanted it, and then save that file. And then on a day-to-day basis, as we went from show to show, we weren't importing the complete system fresh from SoundVision every time. We were actually taking an existing file and modifying it and updating it to match the requirements of that particular show. The reason is this, really. You can see how much information there is laid onto that Network Manager page and how complicated that file is. So actually to rebuild that for every show was going to be a really, really time-consuming job. And that's time we just don't have of a day. So you're seeing that file there, that's the show file from Vienna in Austria. And that is the complete system. So that's all the ring delays and all the ground delays up as well.
Maybe to say the forced P1 you see in the top right corner, the last one, that's the one we used for if we had to tie into the house system, which I believe happened 2 times.
Twice, yeah.
Yeah. And this P1 is not in the drive rack in front of house. That one was based in the stage left first delay tower rack, where we ran into the house from this point.
Got it. So you had an additional P1 for house processing, delaying, EQing, and also used it as an interface to either give them an analog or AES, whatever they wanted or could take, feed.
Exactly, yes.
And I'm assuming most of the time houses like feeding the VIP boxes, maybe a random shadow speaker that's under an overhang that you can't cover practically on a touring situation.
Yeah, these kind of things.
Primarily VIP boxes and things like that. It wasn't often. We had one situation where we ended up trying to use a house system to cover the shadows, and actually it just didn't work. We couldn't make it work because of the way their system was laid together. So we ended up having to put some more of our speakers in to fill that void. So this gives you a map of how the site's laid out from overhead. So you can see the front of house tower, front of house area is in that bottom delay tower. And that overlay there gives you an idea of how the cabling structure works and how it's all laid out. So you go from the drive rack, which is the yellow square in the front of house tower, to that first delay tower behind front of house, which we always use. And then that delay tower distributes from there out to everything else. So that delay tower, the switch running in that delay tower was also UPS. So if we ever had any power issues, that switch was protected and we wouldn't have to wait the time it took for it to reboot.
Got it. And then, so when you did the 3-tower mode, obviously the front of house tower always stayed, and it looks like front of house is on house right, pretty far over actually. It's not that typical center position.
No, it is a long way off center. Yeah, it is a long way off center. And this was built like this for a couple of reasons. I mean, so the towers behind, the physical delay towers, were always going to be in those positions, give or take, for pyro and lights and arson and all the rest. So production didn't want to take up more floor space by adding an extra front of house position in the middle somewhere that was going to end up as arse and light. And also they're concerned about sight lines because the B stage, the support band B stage and support band stage is on top of the lighting front of house on house left. If you put that in the middle of the stadium, you're actually killing a huge number of sight lines down the center line to the stage.
Oh wow!
So actually, practically, it makes much more sense to put that on way off on the side.
So I didn't know. So your opening support band had to play from 50 meters in front of the PA?
Yep, indeed.
That makes sense.
2 girls and 2 pianos. Took a little bit of getting used to, but they figured it out. It was all good in the end. Yeah, it was interesting for the guy mixing. For Jurgis, who was mixing them, was mixing from our front of house position on house right to a band that he couldn't see on house left, which always makes life interesting.
And
so we're just going to...
Sorry about that. Yeah, go ahead.
So we're just going to take a quick look at a couple of sound vision files, a couple of pictures, and some 1 or 2 things that jumped out on us on the tour. So the first one, this is a mapping of Frankfurt. So this is a fairly average stadium. It's got 3 ground delays in it and some ring delays. So that's what that looks like. When we were doing the sound vision and when we were looking at SPL and SPL response, there are a few things we were particularly looking at. So one of the first things is we know Rammstein's going to be a loud show. That's just the way it is. It's a loud band. All the audience are used to it being loud in the environments they've seen it in before. So it's going to be loud. So given the size of the system we're running and the size of the environment we're in, we're very concerned about the SPL delta from the barrier to the mix position. Because if the guy in the tent, if Olsen in the tent at front of house is running along with what he thinks is acceptable, and there's a 6 dB delta to the barrier, potentially we're doing people real damage on the barrier. We're potentially really endangering people's hearing. So that's not acceptable. So we were looking for a dB and a half of that kind of order, delta, no more, from the barrier to front of house, which is 50 odd meters away. So there's a little bit of work to be done there for a start. And also we're very conscious about matching the tonal balance. So looking at the 2 curves, the low frequency curve that you can see in the SPL target and the high frequency 1 to 10K curve, and making sure those were reasonably homogeneous between the 2 of them. Alongside that, trying to make sure that the delta across the whole stadium is not too bad. We don't want the front row experiencing 8, 10, 12 dB louder than everywhere else in the stadium. We want it to be as even as we can get it. So.
Yeah, and I'm assuming this is a typical band production scenario. We want it to be even and equal everywhere, but there's a practicality to how even or equal it can be. Was your barrier of success plus or minus 3 dB, or a little more lenient than that in a stadium?
It's a little more lenient than that, particularly when you have to start making decisions in stadiums that have roofs, that have rollover roofs at the top. Because if you end up firing lots of energy up into that roof, potentially you're going to create an intelligibility issue. So sometimes you have to make a decision that, okay, we're going to make it a couple of dB quieter up there than we'd really like it to be, but we're going to sacrifice the SPL to gain intelligibility by not washing the roof or not overshooting. All of these problems that we all see regularly doing big shows become even more exacerbated when you end up doing stadium shows.
Sure.
There's one that immediately springs to mind where, weirdly, the noise monitoring position for this particular stadium is on the upper far corner of the seats. So it's just commonly known that you just don't point speakers at those seats, because if you do, you're going to go way over the local noise limit. Whereas if you don't point speakers at those seats, you sacrifice the audio for those seats. But the reality of it is that 95% of the audience get a decent show.
Right.
So there's all sorts of little weirdnesses going on like that.
So this is a bigger system. This is Moscow now. So this is a big stadium, one of the bigger ones we played. So this is now 4 ground delays and all the ring delays. That's Moscow. The ring delays, if you look at the ring delay speakers, are actually located in slightly not the most ideal positions. So you can see there's one there, and then they go around the side. That one is not really in the kind of place we'd want it in an ideal world, but with ring delays, we're limited by what we can fly off in the roof. So that's entirely down to the limitations we have in that particular stadium. The next example I want to show you is St. Petersburg. So we back-to-back from Moscow to St. Petersburg with the ring delays, which is quite a lot of work. But St. Petersburg is a very, very big stadium. The roof in St. Petersburg is 50+ meters up. So I'm just going to switch to sound vision real quick. So this is the sound vision file for St. Petersburg. So I've just got the ring delays switched on at the moment. And okay, it all looks okay. You know, this was our initial starting file with the information that we've been given by production and by the local stadium. When we walked in the day before, what we found was that some extra seats had materialized, which were up here. So this extra seating had appeared, all these seats around here, and worse still, I'll move you out of the way a second, Scott, an extra screen had appeared there. So they'd started installing Jumbotron screens in the corners of all the stadiums. So this screen had materialized, which, as you can see, there's our ring delay there blowing straight into the face of that screen. And we now have a big masked area around the back of this screen. So that solution really is not going to work. So we ended up having to remove the ring delay that we were going to use, which was this guy, and put a smaller one in flown lower, which has covered this area nicely now, and it's got the worst of the overspray off the screen. Unfortunately, if we just tip this drawing up, you can see there's a big hole around the back of the screen now. So one of the nice things about using L-Acoustics as a manufacturer is that wherever we go in the world, I'm pretty sure that I'm going to be able to get hold of some L-Acoustics products. So we got the local promoter to do a bit of a phone round, and they found us a Cara bumper and a couple of bits of Cara. And so we ended up putting a little screen fill in around the back of the screen, just here. So if I spin the drawing around now, you can see just at the back of the screen down the corner there now. There we go. Just here, there are now 6 Cara flown behind that screen just to fill that area in, which it doesn't look perfect on the sound vision drawing, but it worked pretty well in reality, and it was certainly a better solution than having nothing there at all. So we used a couple of spare motors off the tour, and we used some spare Cara that we had and got the bumpers and things locally. The only challenge with that solution was the only amp rack we have for it was down on the floor down there. So I think that cable run was 175 meters in the end.
Well, I mean, it's once again a better solution than not having one. Now,
yeah. We didn't need low frequency out of it, so. You know.
Yeah, you mean there's enough low frequency in the system, I suppose, right? Already.
Yeah.
Now, in that situation, did you guys have an audio advance team that discovered this, 4 days out or 5 days out, or did production happen to kind of recognize? Nobody noticed this until you walked in, of course, at 7 a.m. on what, the day before the show?
So the guys building the steel had been there for a couple of days, and nobody had. I just don't think it had kind of clocked to anybody that was going to be an issue. But fortunately, the ring delay system went in on the day before the production load in, and I went in. I happened to be going in with the ring delay guys that morning because I wanted to have a look at the place. This is a stadium I'd never been to before, so I wanted to see the place for myself. So I happened to go in, which gave me the 24 hours I needed to, as the crew chief, to go and figure out what we were going to do and find the bits we needed. While the 2 ring delay guys, Lucian and Damien, got on with flying the ring delays, which actually in this building is not easy in itself because we were carrying 50-meter motor change for ring delays, and we ended up putting stingers on the motors to get the chains up to the roof.
Sure.
So yeah, it's a really, really big building. Back there again. Okay, so just to give you an idea of deployment and what we were doing in terms of deployment, we were unloading 5 trucks, and from the time we opened that first truck door to the time we were ready to time align the system was usually in the order of 7 hours. It was a little bit faster than Navicat a few times and a little bit slower on a couple of occasions, but it was circa 7 hours. That doesn't include the extra hour that Nils and Fada would use in the morning to verify the sound vision drawing.
although we were getting good information in the most part, we would always come in and verify the sound vision drawing. So we're checking to make sure the delay towers are in the right place, that they've actually gone in where they said they were going to. They haven't had to move them because of a fire escape or something that people weren't aware of. You know, just checking to make sure it's all gone in the right place. The drawing that we have is the drawing that really is the stadium and all of that kind of stuff.
Got it.
When it came to load out time, we were loading out from the time the last note was played. We were loading out about 85 to 90 minutes every night, and that's the lot. It was a little bit longer sometimes with the ring delays, but usually that was the kind of order that we were out in. Everybody had their own specific tasks, both in and out, and actually it's a relatively small crew. There's only 10 guys on the core crew. 2 of those guys are dedicated to the ring delays, so Lucian and Damien dealt with the ring delays only. They would pitch in and help with everything else if they were there, but if the ring delays weren't on that show, then it would be 8 of us. So 2 people on stage left doing stage left PA and system engineering. 2 guys on stage right would do the stage right PA and then deal with all the ground speakers, all the subs, all the front fills, all that. 2 guys looking after front of house and the ground delays, and then 2 more guys doing the stage and the monitors. So actually, in terms of flying the PA, there were only 6 guys touching the primary PA, unless the ring delay guys were there to help. So it's quite a small crew for such a lot of speakers. And what were we talking about in terms of the speaker count? So these are the main hangs. So you've got 18 K1 and 4 K2, and then 20 K1 subs flown alongside them. And you might notice up at the top here that there are no motors hanging these speakers. So actually there's a bit of a custom rigging piece that's gone into to pull those up into the air. The other cool thing about all these speaker hangs is that lighting department decided to use them as part of the set. So they lit them all, which looked really impressive when they were all lit up.
Now, did that mean the lighting guys helped fly them and take them down then, right? Since it was a visual element?
Absolutely. Totally. Yeah, completely. No, the only thing they did was get their lights out of the way quickly so we didn't squash them. Other than that, no, they definitely had enough of their own gear to be dealing with.
Well, and another reason for the K1SBs is that they can match the shape of the actual main hang. So the hangs kind of design-wise look the same.
Yeah, there's a question we've been asked quite a lot, that why we weren't flying KS-28. If we just go back to that picture real quick, why we weren't flying KS-28 and we had them all on the floor. Unfortunately, if we'd flown a hang of KS-28 down the side of that main hang, it would have ended up being in front of the hang. And just from an aesthetic point of view, the set designers were really keen on having the aesthetic of 2 similar looking things rather than a different shaped thing.
Now, were you using at all the acoustical benefits of the K1SB beside the K1 to steer the low end? Was that a concern for your design in particular or your artist?
Yeah, it was. I mean, this is something that Vada pointed out, and Vada pointed out very early on in the process, given that he knows the band so well, that the band really don't like low frequency on stage. And it's a concern that Alex and Sky, the 2 monitor guys, had, that whatever we did with this system and however it's scaled up from arenas, it had to be the same, that we minimize the low frequency on stage. So by flying those K1 subs next to the K1, we're really making sure that beam steers away from the stage and we don't end up upsetting everybody on stage. Yeah, that was definitely a concern. When I was talking about the rigging earlier on, so you can see this is the top frame that those speakers hang off of, and these ropes are currently carrying the steel wires. That steel wire hook there is a 2-ton steel wire, which runs over this beam through the pulleys and then down the other side, and that attaches to the motors, which are in a cart down here. So you can see 2.5-ton load guards there upside down with their chains running out the pulleys in the bottom. And that cart stays together as one and just rolls in and out to every show. And those motor chains are fed through pulleys on the other side, which then go up the back of the tower to pick up those steel wires. So you can now see in this picture, the end of the steel wire is down at ground level, which means the speakers must be up in the sky at the other side of the tower. But it was a nice, neat rigging system to get the motors out of the way, because we just couldn't. We didn't have enough space to have those motors hanging up above the speaker hangs.
Oh. Now, wow. I mean, it's just incredible when you start thinking about all the ramifications of each little design element, right? You know, towers are so tall. Was there a limit? I guess why not just make the towers 4 meters taller? Seems like an easier solution to me, or is there challenges on that?
So yeah, absolutely. You're right. If we spin back to this photograph, so on the top of the towers, there are these lighting pods, which go up before we go up, and then the frame that you can see that's sat there flips from vertical to horizontal to pick our speakers up. The limitation was this tower and then how high they wanted that pod. So there was a negotiation between how high we needed to get the top speaker and how high they wanted the bottom of the pod. And between the two, we came up to an acceptable compromise between the two. And that compromise meant that we couldn't have the motors up there. So we had to come up with another plan for the motors. And actually, that pod is lifted by a similar pulley motor system. So they all live down at the bottom of that tower.
Wow.
Which is a really neat solution. Yeah, it took a load of figuring out. The rigging department had a lot of figuring out to do, but it is a really neat solution. And you can see if we look at the side hang obviously needs to be flown higher because it's pointing up into the side bleachers. But with this, we've got the motors above the hang, and this is just a standard Stagecoach motor grid that's hanging those. So that tower is much taller.
I'd say a slightly large side hang there as well. Is that another 20 or 22 enclosures?
Yeah, 20K1 and 4K2 again. And that's the limit. That's as many as we can get up there from a weight point of view. The tower won't take any more. So it's interesting when you start to scale this up that you end up on the limit with everything. I mean, 20 and 4 would be usually would be a massive main hang for an enormous festival, and we're using it as a side hang.
That's wow.
So that's the pit. So that's subs and infills. And I was talking about the trucking and all the speed we got this in and out. Part of the reason we could get in and out so fast is that we're not taking it all apart every show. So the guys at SSC Solotech custom built a load of stuff for the tour, like this plate that sat on the top of these subs. Those car never come off that plate. They stayed there the entire 25 show run. So that rolls into the truck exactly as you see it. You just unplug it, roll it away, into the truck it goes. We were carrying 68 KS28s, which all lived in the pit.
Maybe the double high stacks you see in the center. The two high stacks, we stacked them on top of each other. So we had, like, when they went into the truck, they've been 4 high, just with a wheel board in between, which has also been custom made by SSC Solotech.
Yeah, but again,
to save some truck space.
Yeah, just wasn't going to fit otherwise. The other interesting thing about this show, from an equipment point of view, is the amount of abuse the equipment got. And I don't mean abuse in terms of we weren't looking after it, just in terms of what it went through because of the rest of the show. So that's the state of a pair of KS28s in the pit after the end of a show. So that's the foam that comes out of one of the special effects that ended up hosing the KS28s. And we didn't lose an 18-inch driver the entire tour. The entire tour ran without losing any 18s, which was pretty impressive when they were getting that wet every night. And there's the ring delays. So the ring delay system was 8 hangs of 12 K2 as a maximum, and they were flown off of these spreader trusses on almost every occasion to be able to stop the hangs spinning. And most places you can't get 2 conveniently placed motor points on these roofs, so we ended up having to put spreader trusses in most of the time. And all the cables that are driving the K2 for the ring delays are 50 meters long, so they're big long cables down to the ground.
Did you have to did they have to tie those off laterally to prevent them from blowing in the wind, or was it, generally speaking, not too bad, even with the spreader trusses?
It's not too bad. The guys did quite a lot of work. You can see just see it in that photograph there. There's a pair of turnbuckles and a piece of steel that they set the angle with. They set the horizontal angle with the azimuth with, and once that's all tied off there, generally with 12 K2, they stay there pretty well. Most of the stadiums are reasonably well protected from wind.
Okay.
So it's not normally too bad.
No, that's good.
It worked pretty well. The next show we're looking at ways to make the guys' lives easier flying them, particularly when they're flying like over the top of seats and things like that. It can be a real pain to get those in, but
sure. Yeah,
we're looking at some solutions as to make life a bit easier. So the calibration routine for all of this, we were using Smart 8 to calibrate and tune the system with TG 1000 radio mic systems. And we were only using 4 radio mics, and we weren't using any more than that. I have to make quite a lot of fairly careful choices about measurement locations, as you do with all shows, but particularly with this, given the environment. So quite a lot of the stadiums have big concrete walls, which create some really weird reflections. In an ideal world, we want to be taking the measurements in the same place, roughly the same place every show. But sometimes that's simply not possible. Sometimes there's a cherry picker in the way, or there's something going on that means we can't. And you would think, well, just why don't you just wait for the cherry picker to get out of the way? Well, the reality of it is that the amount of time that we have to tune this is fairly small given the size of the system. So counting the subs and the front fills as one source, we're 19 individual sources on this show when everything's up. And we were usually getting between 60 and 90 minutes on the load-in day, at the end of the load-in day, to do the time alignment before we start tuning. And usually the tuning would happen on the show day, because quite often we're constrained by either a pyro test or by the local noise restrictions or something, which meant we couldn't make noise on the load-in day, any real noise on the load-in day past tuning. A question that's come up a few times is why we didn't use M1. When this show was put together, M1 had only just been released on beta, I believe I'm right in saying that, Scott. And it took some time and some effort between us and Luminex and L-Acoustics just to iron out a few tiny little bugs with AVB and things that we had. And by the time we'd all spent the time figuring that out, there wasn't much inclination to then have to change all the firmware on the whole system to be able to use M1, which was still in its early beta. So the decision was taken that we would stick with Smart for this iteration of the show. So once we get into the show itself, another question that we've had from a few people as to why we weren't using remote control systems for tuning during the show. We have a remote control system when we're tuning the system before we get into Showtime, but actually the tuning process for us during the show, or the listening process for us during the show, was people driven. So the PA techs, the techs we had would go out with radios and relay back to front of house. We just struggled a lot in stadiums to find a reliable, stable RF system, Wi-Fi system, whatever, that didn't get interfered with by the 50,000 mobile phones that turn up and the venue's Wi-Fi system and all of that. Yeah, so we definitely used human relay rather than remote control for that purpose. It was quite good though, because quite often the guys going around checking would bump into local promoters or whoever it happened to be and talk to them about what was going on. So it was a nice source of information for us. We did use the P1s, part of the P1 system, to get an atmospheric information, and so we were getting temperature and humidity information out of the P1s. And you can see that the kind of values we were running for SPL during the show, which is pretty loud.
So you were 100 dBA LEQ 60. So the average energy over 60 minutes was 100 dBA. So the song by song, you could be 105, 106, 107, 108.
It didn't usually get that loud. It was, you'd see peaks in the 105, 106 kind of space for some songs, and then it would drop for other songs. I mean, Olsen, the guy that mixes it, is very dynamic in the way he mixes, but is also very good at managing energy. He knows that some songs are louder and some songs are quieter, so he's very good at managing the way that works. And we have a good I have a good working relationship with Olsen. We talk about this kind of thing, and there have been venues where we had to be a lot quieter. The venues we were clamped to 99/15 at front of house, so you just have to figure it out and make it work. But yeah, in the most part, if you took an average across the 25 shows, that's probably a reasonable average across the 25 shows. Yeah.
I'm a little surprised the C number is not actually bigger. In my mind, Rammstein is this mountain of low end, but 12 plus 12 dB is not a crazy number, actually. It seems quite in line.
It varied. I mean, it definitely varied. Song to song, it varies. Obviously, some of the songs are a bit lighter and a bit quieter. Maybe quieter's the wrong word, but a bit lighter and a bit less low end intensive. But yeah, it could be 12 dB or anything higher. I mean, 17, 20 is not uncommon, but sure, that would be more of an instant reading rather than a long-term reading.
Yeah, got it. Understood.
So, unfortunately, the next tour, we were talking about the next tour. Unfortunately, the next tour is still up in the air at the moment. There's been no official announcement about what we're doing. But from the audio point of view, we're definitely continuously trying to improve this and make it better. And because we're going to the US has some really interesting, unique issues with doing stadiums. Like, we can't fly ring delays in most of the places. And most of the upper bowl seats are really, really high. So we're looking at whether we have the right configuration in terms of speakers and all of that. We can't change the towers, unfortunately, so we're trying to figure out whether we have the right configuration to take to the US with us. The next tour definitely has more. So we'll be hanging another set of speakers further round the corner on the stage to cover the 270. And that's primarily not because they want to sell much further round. It's primarily because we want to get the coverage right up in the top corner of the furthest round seats better than it currently is. And so there's going to be some more speakers. With those extra speakers, we may well end up with 200 plus amplified controllers, which will be interesting. We're definitely going to review the measurement system. We may end up using M1 on the next run. So that's definitely something that we're looking into and considering at the moment. We're looking at Milan now. So we're looking at a redundant AVB system, which will be interesting. And possibly console integration if the Alton mixes on an S6L. So if the S6L platform releases a Milan card, then we might look at integrating the console via AVB as well.
So yeah, obviously you brought up a point, the redundant capability of Milan AVB. So the ability for the P1 to send out over 2 physical networks. I guess that brings up the question, the $1 million question. Did you have any AVB failures, or were there hardware failures? And you had a redundant system, right? So it would, if that happened, it would just switch over to analog.
Yeah, absolutely. Yeah, it would drop immediately to analog. We had a couple of occasions where we had a small part of the system drop out to analog. It was usually the ring delays. And actually, it tended to be a hardware-related issue rather than an AVB network-related issue.
Sure. So you lost power at a switch point or a cable issue or something like that.
Precisely. Yeah. We lost a cable at one point. We had a glitchy power issue on a couple of ring delays when we were running on local power, and so the system would drop. You know, we would see it drop off the network. We would be aware there was an issue. As far as the audience was concerned, it would carry on regardless because it just flopped straight to its analog input. And then we'd go out and figure out what's going on and try and reboot the system. But in terms of AVB stability, we had a couple of occasions where getting the system online, we had to reboot a switch or we had to replug a cable or something like that. But once it was up and running, it was really, really solid. It was rock solid. It was very good. Yeah, there was one of the things that actually, it was the first time I'd toured a big AVB system. So I went into it not with concerns, but the previous iteration in terms of Dante was a very known entity, and this was the first time that we'd done something this big with AVB. And actually, it worked. Yeah, it worked beautifully. Very quickly on the third, it became something that wasn't of concern, which was really nice.
That's great. And obviously with the analog fallback, so for people who are haven't had a chance to experience this, effectively the amplifier, if it loses the AVB source, i.e. the network, it'll switch over to its defined backup, and it could be AES as an input or analog. Analog to me makes so much sense in many ways because it's just simple and easy to patch, easy to test, easier to distribute amongst 186 amplifiers, which is difficult for something like AES. And then it takes 100 milliseconds, 200 milliseconds for the amplifier to switch its clock over and grab the analog input. So for the audience, they just hear a little glip, but everything keeps going. And it will stay in analog then if you restore the network. So did you usually leave it in analog for the rest of the night, or if the network restored, did you switch it over?
No, we usually restored it back again, actually. Usually the guys, we're in a fortunate position to have enough crew that the guys could go and solve problems and go and fix things. And once it was resolved, yeah, we'd get a radio call and front of house, and we'd usually flip it back. I mean, we did some A/B testing between the AVB and the analog before we left the pre-production facility, and there is definitely a difference. There's definitely an audible, sizable audible difference between AVB and analog. So we'd much prefer it to be running on AVB, absolutely. So it was switched back if we had the option. The other interesting thing to touch on with AVB is that with a system of this size, we actually almost reached the hop limit. So. Right. Maybe you want to touch on the hop limit issue.
Yeah. So for those who haven't yet been to maybe the presentation yesterday from Vic and Francois, or if you haven't yet been to the one tomorrow because it's still today, AVB can operate within a certain number of hops, or let's think of that as switches in between. Now you were running the network in, let's say, classic mode. So each device, the P1 has a switch built in. So there's actually a hop within the device. And then you hit a Luminex switch, which then went to another Luminex switch and all the way around. And you were also daisy chaining a few amps at times as well, so you didn't have to have as many distributed switches.
Yeah, right.
Because each LA12X is both an AVB listener, can receive audio, but it can also pass it through its switch. So you can have 12 switches in line, i.e. the devices can be 13 points apart, if I recall. So you were at 11 hops, I think, to the furthest point, or 12. You were right at that limit.
12.
Yeah, right at that limit.
12 to the furthest one.
So what's neat about AVB though is whether there's one hop or 12, the audio is always played on every device at exactly the same time, and there's nothing you have to do to set that up. It just does it, right? So had you tried to go further, it just wouldn't connect, or it would pose an error to you at that point. So if you went to redundant Milan, the difference here is you can no longer daisy chain the amps, which means each rack with 25 amps, and it has to have a switch with 48 ports or 36 ports. And then you have to have two of them because you actually have two physically separate networks. That way, if you had a power glitch on one switch, the secondary network would just instantaneously transmit the audio. You'd have no audio loss at all. Audience wouldn't hear anything. There'd be no degradation to the signal.
We're also, the interesting challenge with that as well is we're also doubling up the fiber.
Sure.
So if we go to a redundant Milan system, at the moment we're running a ring, so it's a continuous ring all the way around all the 16 amplifier racks. But if we add the Milan in, it's going to end up being yet more fiber.
Sure. So it's just a cost-benefit analysis. And this is of every show of redundancy. It's a matter of whether you need instantaneous recovery that's seamless, and that's important for some events, but it's maybe less important for others where you just need redundancy that's passive, meaning you don't have to take action, right? If something goes wrong, the amplifiers make a choice on their own. They switch instantly. And maybe there's 100 milliseconds of gap of audio as that amplifier reclocks to the internal clock, which is not tragic. It's not ideal, but the show's going on. People went, that was strange for a split second, and then they forget and they continue to have a good time.
I mean, the other really cool thing about AVB versus the Dante type setups is that we didn't have to do anything to the switches. The switches are totally plug and play, so there's no having to worry about putting virtual networks in and all of that. With a Cisco switch, that turns into pretty serious IT. Well, with the AVB compliant switches, the Avenue compliant switches, it's just plug and play. You just plug it in and it figures it all out for itself, and off you go, which is nice. If you have a switch failure, you don't have to worry about reprogramming it before you put the new one in. You just rip the old one out, put the new one in. It's a really nice feature.
Very cool. Very cool.
So that gives you a quick idea of the racks for the next tour. So we're making a change now, so we'll end up having a new amp rack on the floor. One of the things we didn't like on the last tour was the length of cable we have on the subs. So some of the subs had 30-meter cables on them, which isn't ideal. So we're going to get the amp rack on the floor in the pit, so we can now have much shorter cables on those, which will be cool. So that's another thing we're changing.
Which is
going to go on.
Putting the sub amps on the floor also gives us or frees up the space to put the additional amplifiers for the new 270 degrees hang into the side hang amp rack as well. So
the only challenge that we've got, as Scott was just talking about hot limits, is the potential hot limit. We may end up hitting the hot limit, so we're going to have to be really careful with how we configure switches for this now. But yeah, and all that remains for me to say is thanks to the rest of the guys that were on this amazing journey with us. That's a list of everyone involved. And so thank you to you, Scott, for inviting me to talk about this a little bit.
Yeah, no problem. So we had I'm just checking the moderation of the Q&A, and there seems to be a few questions filtering in, and maybe Nils or Nick, you can help answer this a little bit. So someone was asking just like what the target tonal balance was, what your pivot point was, like what do you find for, obviously in general maybe, and this particular artist or band, and did you do a lot of that work in Sound Vision, or did you do that? So this is a 17-part question, I guess. Did you do that in network in tuning and network manager?
I would say to answer the last part first. Where did we do that? Well, we came up with what we were aiming for to start with in Sound Vision, and then actually quite a lot of the work ended up being done on the ground. So we would take measurements and look at what the system was doing in different places. But in terms of pivot points and targets, fundamentally we're trying to get the same thing across all parts of the stadium. So we're looking for fundamentally the same target shape everywhere in the room. But where that pivot point sits is going to be treated differently for different hangs. So for the main hangs, the pivot point sat at front of house because we were looking at that 1 to 1.5 dB delta from the barrier to front of house, and then a drop past front of house. And because we have big, large, powerful delays on the ground, we can use that downslope of the main hang to get a really nice crossover between main hang tailing away and the delay hang picking up, and make sure that crossover runs in really nice and smoothly. The pivot point would be different for a delay hang because you're going up into the bleachers, so we need to figure out the correct place to put that there, and that's going to alter show to show.
So auto splay within Sound Vision, you could then say front of house, which is at 50 meters, to barricade, which is probably what, 6-7 meters realistically or something like that. You let plus 1.5. I think 6 meters plus 1.5, and then behind it, because you're coming into a delay, you can actually let it attenuate a bit faster, knowing that the delays are going to pick up some SPL.
Absolutely.
And that probably actually matched the tonal shape of the low end as well, right? The low end probably propagated kind of in a similar ballpark.
Yeah, and that was a primary concern as well, making sure that the tonal balance of the system sat together, because Rammstein's is a full range show, so it needs the tonal balance needs to be right, and it's also worth making sure that that's considered, given that we have really full range delays. The delays aren't like a small hang of Kiba or Kara or something.
Sure.
You've got big hangs with K1 on the delays, so they're generating a lot of low frequency in their own right. So you need to make sure as that crossover happens, you have a very similar tonal balance between the two. Otherwise, you're going to hear the change from one hang to another.
Sure, and then the low frequency contour, like in a typical pop rock show, I might say plus 12 dB, with the pivot of the contour at what, 400 hertz, 300 hertz. I mean, what was the target for this particular act in that sense? Do you remember?
It was a little bit more than that. We were looking for a little bit more energy than that. And actually, what we thought we would do to start with, once we got into it and we got Olsen's input a little bit more, and Butter steered this to some degree to start with, but once we got into it, we kind of got a bit more of an idea from what Olsen was looking for out of the system, that actually the super subsonic stuff is of less concern to him. What he wants is that thump, that kick in the chest when the kick drum goes. And so we did quite a lot of work not a lot of work, we did some work in EQ on the low frequency to make sure that he was getting that thump in as much of the stadium as we could give him, and we were removing some of the rumbly waffle kind of information. So that.
Sure. So someone had a question about the ring delay amplifications. If I recall, those were just on the ground, effectively below the delays. Were they clustered together at all, or was it one per ring delay spot?
Yeah, one per ring delay spot. We were actually really lucky because quite often with ring delays, like Damien and Lucian would have been having to carry amp racks up into the roof and all sorts of other chaos. Production allowed us to drop them on the floor directly underneath the hang. So we just had a 50-meter cable swagged down from the carrier truss down to the floor, which was great. Power went in, and we just ran the multi-cores between each amp rack. They had their own little waterproof covers, so they didn't get covered in beer or what have you. And they just sat there and did their thing.
And
we're really lucky from that point of view.
Yeah, and was there any else production? Was lighting there, pyro there, or confetti, or foam cannons? I think. What else did we see? Rubber duckies.
You can see it on the picture on Nick's screen, the last one where you can see the crew. That was the only show where we had some additional lights in the roof because we were doing some additional filming, crowd lighting. That's why we have you can see a few trusses up there, but that was the only show where we had that.
Got it. Yeah, I can see that.
Yeah, but otherwise it was just us sat there, which was great. We didn't have to worry about the amp racks getting covered in confetti or foam. All the special effects come out of the delay house.
Got it. Very cool. Very cool. I'm going to check with the guys. Tony, were there any other questions coming in? I didn't think I saw maybe one about wireless mics.
The only thing that I couldn't answer, because I don't really know them, is that measurement mic system. Someone was asking for some more info on it. What sort of mic is it, and is it phantom power?
Yeah, what was that's a great question. So the question is what your preference of wireless, what mic you use to calibrate, I guess. And then obviously the wireless system, it provides 48 volt, I'm assuming, to the calibration mic. To use are you using an Earthworks or a iSimcom or a Biodynamic or a?
The Bayer, so it's a Bayer TG1000 transmit receive system, and it's Bayer's own mic on the end of it.
Oh, cool.
bomb-proof. They were really rock-solid pieces of kit, actually. It's not. I will say it's not my system. It was a system provided by Solartech, SSC Solartech, and I believe that's what they've kind of standardized to. And I think they're using those because they are one thing built into one, one tube, effectively, rather than being separate pieces. But yeah, it was a good system. It was pretty bomb-proof. Transmission range on it good. Seems you have to get the antenna in the right place, but other than that, yeah, they were pretty good.
Yeah, I suppose for you guys, the challenge of the antenna is you had a giant steel tower directly behind you as well, which maybe caused some challenges.
Yeah, we're roofed in the front of house tower, so yeah, there's a big steel tower over the top of us as well. So we ended up having to put the antenna outside, and yeah, but yeah, they work pretty well. Even for doing ring delays right up in the roof of stadiums, they work pretty well. Yeah,
and so obviously the other thing you're talking about is the challenges. We're going to go to the U.S. and stadiums in America, as all things in America are slightly larger. So the average stadium size is 80 to 90,000 seats. You guys are playing probably, and they don't have roofs very often, or if they do, they're 100 meters high instead of 50 or 60. So that's going to be quite enjoyable. Does that pose? I suppose the no roof is a good thing for pyro. So it means there's probably a little more freedom in stage placement. But you're not going to be able to do ring delays at most of them either. So you're going to have to think about your delay system.
Yeah. Actually, the no roof thing is both a blessing and a curse. Obviously, it's a bit of a curse because we can't fly speakers up there, which sucks. But the fact that you effectively blow straight over the top of the audience and there's nothing behind or above to fire into and reflect off actually means that you can run the delay towers harder than we could otherwise.
Sure.
If those delay towers are firing up into a roof. So actually, while it's not ideal to have the speakers that far away from the audience, it's a manageable situation. And this is definitely something that we're looking at, whether we have the right selection of boxes, because obviously with a big K1 hang, we might not get as much up tilt available to us as if we turn that into a big lump of K1 pointing way up the top and then some K2 lower down.
Got it.
Yeah, so we're looking at correct cabinet selection at the moment for all of that.
Got it.
Absolutely.
Got it. Well, I think that's about it we've got for questions coming in. Nick, I really appreciate your time today.
Given that I'm L-Acoustics trainer as well, if people have questions post this that they want to hit me up with, then they can get me through the L-Acoustics website. So I'm happy to answer people's questions if they think of things they want to talk about, or some more in-depth technical stuff that they want to ask questions on. That's great. People can hit me up with those questions. I'm glad to answer them.
Great. Well, thank you, Nick. Nils, it was great to have you on the call as well.
Thanks for having me.
1/8 of the audio team. Sorry, this is actually about 1/5 of the audio team present in the call, so that's great. Yeah, 1/5. There you go.
Excluding the engineers and the record guy. Yeah. So.
All right, we're okay. So we're at 1/8 again. We're back to there. So that's fine. But no, I really appreciate your guys' time today. I think it's great for all of us to spend time talking about the shows we're doing, we've done, and we hope to be doing in the near future. If everyone out there has some questions or comments, please don't hesitate to post it. If you are interested to learn more about AVB, tomorrow, Etienne Cortel and Daniel Krona are going to present a really in-depth presentation about AVB and how it actually works, really deep into the technology itself. So please don't hesitate to join us. Next week is going to be all about ELISA. So next week, starting on Tuesday, is going to be all about ELISA. So if you are interested in learning about the future of sound, please don't hesitate to join us next week. Nick, thank you so much. Nils, thank you so much. Guys, everyone out there, please have a great rest of your day, and we'll see you tomorrow. Thank you much.
Thanks for having us, Scott.
Thank you for having us. Thanks.
Bye, guys.
Thank you.
Bye.